Okay lads, I'm just going to go through some trig problems. I had a great start with this video by getting the first one wrong, so hopefully I don't make another mistake now that I've refreshed myself on how to do trigonometry. So the first thing I want to do is just write down my mnemonic, soccer toa, just to remind myself of what ratios of the right angle triangles I'm using. So this first problem has got a little bit of working already done because I've already attempted this video once, but we're wanting to find the side x. Now these are all multi-step problems because we're not dealing with right angle triangles initially, but if we were trying to find the side x, we would need to find first that vertical height of the triangle. So if I was finding that vertical height of this triangle, then I label the sides O and H, and I look at which part of that mnemonic I'm going to be using to solve, and it's going to be sine, isn't it? Because it's opposite and hypotenuse. So that means if I took sine of 39, that would be equal to, I'm labeling this one y because I want to find x, so I need some other variable there to stand in for me. I could use h, but whatever. So that's going to be O over h, so y over 47. And when an unknown is on the top as the numerator, we can just multiply by that denominator. So 47 sine 39 is equal to y. So hopefully you're pausing the video on each of these problems for the rest of this video and giving them a shot yourself. So on my calculator, check them in degrees. I go 47 sine 39, and that gives me y. I'm going to call that 29.6. Now that I have 29.6 as my vertical height, I can find x. So again, it's O and H. That means that if I take sine of 60, that's equal to O over H. So that's going to be 29.6 as my opposite over my unknown, which is x. And now my denominator is the unknown. So I do this thing where I can switch both of those, and so x becomes sine 60 and sine 60 becomes x. So x is going to be this answer here, that previous side length, divided by sine of 60 degrees, and I get 34.2. 34.2, and now I need to check my units. It's meters, so that was meters for those side lengths. So there's the first one done. Here is the next one. So finding the side length x. So that's from here to here. We've been given 9 for this part, and again I've given you the hint. We want to find this vertical height. So this here is a right angle triangle. We're dealing with the opposite side to that angle, and we're wanting to find the hypotenuse. So maybe I'll use h for this one. I want to find the height, and sorry, that's the height, and it's not the hypotenuse, it's the adjacent, isn't it? So in my mnemonic, I'm working with O and A, and so it's tan. So if I take tangent of 35 degrees, that's going to be equal to O over unknown, so that's 9 over h for the height of the triangle. My unknown is on the bottom, so I can switch those. H is 9 over tan 35, so 9 divided by tangent of 35 gives us 12.9, and there's no units on this one, so 12.9 is the height of this triangle. Now that we've got the height, we can calculate this length x here. So label my sides. I'm dealing with the opposite and the adjacent, so it's tangent again. So if I take tan of 61 degrees, that's equal to O over A, so that's x over the height that we've just calculated, 12.9. And now my unknown's on the top, so I'll multiply by 12.9. And on my calculator, that's going to be this answer that I've already got, times tan 61. The reason I keep the answer in there is because it just makes this a lot more accurate. This rounding, the error in my rounding isn't carried forward in the problem, but you wouldn't be marked down for that. So it's 23.2. So x equals 23.2, and I don't know what the units are because I didn't give it any. So that's it. These is 2 steps. Pretty much any triangle is made up of 2 right angled triangles, and in year 12 you see how these rules actually mesh together to give some trig rules that are a little bit more elegant than the right angled trig. Okay, next problem is I want the perimeter of this triangle. So you can pause that and give this a go, but I want the perimeter. Okay, so we've only been given this angle and this length here. So what I might do, I haven't actually done this problem yet myself, I've made it up, hopefully it works out, but I can find this side first. And when I have that side, I'll be able to find this side, and then once I've got both of those sides, I'll be able to find that third, because I've got a right angle triangle in here, a right angle triangle in here, and they both make one big right angle. So let's have a look. We always label first, so I'm going to deal with O, the opposite side, and I'm going to call, and this one that's a right angle, so this must be H, and so I'm going to find, I'm going to call that X. I'm going to find X first. So it's sine rule. Sine of 58 is equal to the opposite over the hypotenuse, and that's 12 over x. Unknown on the bottom, so I do the switch. X is 12 over sine 58. So 12 divided by sine 58, I've got 14.2. X equals 14.2, and it's meters, isn't it? Okay. Now that I've got X, I want to find, I'm going to call this Y. And so now we're looking at the big triangle with a side length, and that's opposite. So I'll label that opposite. And this is not the hypotenuse of the triangle anymore. This is now, for our second triangle, this is the adjacent. So O and A is tan. So if I take tan of 58 degrees, I get O over A, toa. So I get Y over, what was that length? 14.2. Unknown on the top, so I just multiply by that number there. 14.2 of tan 58 is Y, and now it's just plug into my calculator. So see how I've got the answer stored still? I can just go answer times tan 58, just to keep it as accurate as possible. 22.6. Okay, and now you could use right angle trig to calculate this side here, or it is a hypotenuse with 2 given sides. We can actually use Pythagoras. So down the bottom here, we're going to go Z is 14.2 squared plus 22.6 squared, and that's all square rooted. And so I go square root in brackets 14.2 squared plus 22.6 squared, close that bracket. Z is 26.7 meters. And so the perimeter, hopefully I'm in the shot still, so the perimeter is going to be those 3 sides added together. 14.2 plus 22.6 plus 26.7. I'm not going to try to do it in my head. 14.2 plus 22.6 plus 26.7. We have a perimeter of 63.5 meters. Amazing how much information you can get out of a right angle triangle given just a vertical distance from one side and an angle. Okay, here's another problem. What is the area of this triangle. And so remind ourselves that area is a half base times height. Now we don't have a base and we don't have a height. Luckily we're dealing with a right angle triangle, so if we call this our base, and we can call this vertical distance here our height, you can see that I've now split this problem up into a couple of right angle trig problems, and we'll be able to find the area. So let's find the height first. Well, labeling shows me that that's O and H, so I'm using sine. So to find H, I'm going to be using sine 42 degrees is equal to the opposite side divided by the hypotenuse. So H over 15. 15 sine 42 then, because we'll have to multiply, is going to give me my height. 15 sine 42, 10.0 meters, centimeters. H is 10.0 centimeters. So there's our height. And I just need a base length. So I've tried to I've made this problem a little trickier by having it kind of inverted down. So it just kind of is a bit of a trick of the eye there as well, making it look a little more challenging. So now I'm going to use this right angle triangle, the big one, and I'm going to be dealing with the hypotenuse and an adjacent side, isn't it? It's adjacent to the angle. So cosine of 42 is equal to A, adjacent over hypotenuse. So ka toa. And so what I've got here is 15 over, and I'm calling this B for the base. And so with my unknowns on the bottom, I can just do the switch. So B is equal to 15 over cosine of 42. Right, so 15 divided by cosine 42. Our base is 20.2 meters. Okay, now we have our base, our height. We can calculate the area. So area is a half times 10 times 20.2. And so that's going to be 0.5 times 10 times 20.2. Or I know half of 10 is 5. I could have just multiplied that through. Called that what's going to be 101? 101 centimeters squared. So there we have it. We found the area of a triangle only given one side and two angles, because I'm saying that we've been given that 90. Very good. Last problem for the lesson today is I need the angle when we've been given an area and a side. So just the final problem is going to be a little trickier. Area is again half base times height. So if this is the base and this is the height, that means 100 is equal to a half times this base here times the height of 8. So 100 equals 4b, and so b is 25. So we use the area to find that base there, and now we can find this angle. So we're going to label O and A, and that means that if I took tan of that angle theta, that's going to be equal to the opposite over the adjacent. So 8 over 25. If I want an angle, I take the tan inverse of both sides. So on my calculator, that's a shift tan to get me the inverse. 8 divided by 25, close that bracket, so I'm making sure that that operation is inside the tan inverse. I hit equals 17.7. And I can't forget my units of measurement, and that's an angle. So that was a little tricky, all right? A little bit of understanding of area there, and even a little bit of algebraic manipulation, but you should be pretty comfortable with that. Nice.